Hello everyone, welcome to our course, Design Method of Steel Beams, Basic Principles of Steel Structure. Now here is the content of this chapter, 3.4.1, Overall Stability Design, 3.4.2, Comprehensive Beam Design Example. First, let's see Plastic Design Limit Length LP. The GB code allows a beam to be designed without considering lateral torsional buckling, LTB, if the following equation is satisfied for the slenderness about flange width. When load is on compression side, LB could be expressed as the following 3.48 to 3.49. Second, basic design equation. The GB code recommends the following equation 3.50 for design of beams considering LTB, where MUX is the design moment, SX is the section modulus for main principal axis bending, phi B is the FTB coefficient, which can be expressed as the formula 3.51, where M critical is the beam moment capacity considering LTB. The GB code provides appendix tables for the values of phi B, which is also explained in the commentary of the code. For the general singularly symmetric I section shown in figure 3.16, the elastic FTB capacity can be expressed as the following 3.52 to 3.53, where beta 1, beta 2, beta 3 are related to load conditions, and beta 1 is actually similar to the curvature distribution coefficient CB in AISCS. The detailed discussions on singularly symmetric H sections can be found in the commentary of GB code. In order to compare with the AISCS, let's only look at the case with double symmetric H shape. You can see the figure 3.16 shows the general H section with single symmetry. For uniform bending over LB, M critical can be simplified as the formula 3.56. For H shapes with these elements, corresponding geometry parameters are listed as the following 3.57 to 3.59. Using these expressions, and is expressed as the formula 3.60. The LTB coefficient can be derived as formula 3.61. Using E equals to 2.01 plus 100,000 millimpar, mu equals to 0.28. The GB code equation can be obtained as the formula 3.62. The GB code considers inelastic LTB due to the influence of the residual stresses. When phi B is larger than 0.6 and replaces the phi B by the following empirical equation 3.63. In the previous version of the GB code, the following equation 3.64 is used. Now let me give you an example 3.1. A 6-meter-long simply supported beam must carry a static uniform dead load of 15 kN per meter and a live load of 20 kilonewton per meter in addition to its own weight. The flange is without any lateral support. Select a most economic GB steel HN shape using Q235 steel. The deflection shall not exceed L2 300 under live load. We selected beam HN 450 plus 200 plus 8 plus 12. Now, geometrical property of cross-section is calculated as the following. Each geometry parameter is calculated as follows. Characteristic value of line loading is calculated as the following. Required design load is expressed as the following. Required design moment is calculated as the following. Check bending strength is expressed as the following. And it is found that the bending stress meets the design strength requirement. Next, check overall stability is expressed as the following. First, calculate C. Second, beta B. Next, you need to calculate lambda y, then stability factor phi b. What's more, judge if the phi b is larger than 0.6. If it does, you need to modify phi b as the following, and it is found actual stress has exceeded the design strength. So we need to reselect beam HM 450 plus 200 plus 9 plus 14. Its geometrical property of cross-section are calculated as the following. Now, each geometry parameter of the new section is calculated as the following. Characteristic value of line loading required design load is expressed as the following. Required design moment is expressed as the following. Check bending strength is expressed as the following, and this time it is found its bending strength meets the requirement. Check overall stability. It is found that phi b exceeds 0.6 and it needs to be modified once more. Now, it is found that during this new section, the actual stress has met the design strength requirement, so it is necessary to check the live load deflection at last, and it is found that VQ meets the corresponding requirement. That's all. Thank you for your attention. See you next time.